Okay, so what we're going to talk about is factoring. Today we're going to talk about two types, common and group. And this is an example of a common type of factoring. What factoring is, it's the reverse of distributing. When you distributed, you got rid of a parentheses. What we want to do is create a parentheses when we factor. So we look at these two numbers, the 4 and the 8. We say, is there anything common to both those numbers? Well, 4, huh? 4 can divide into 4 and 4 can divide into 8. 4 is a factor of both of those denominators. So we're going to factor that out. Going to take out the 4. And what we're basically doing is dividing. 4 into 4 is 1, but there's a y squared left. Minus, keep the same sign. 4 into 8, 4 divides into 8 2 times. And you can always check it by distributing. 4 times y is 4y squared. 4 times 2 is 8. So we're doing the reverse. We're, instead of multiplying, we're doing the reverse. We're dividing both of these terms by 4. So that's kind of the idea, but we use it quite often in math. It's think of these as like tools. Like you got an algebra toolbox, and these are two, especially common factoring is one of the tools you're going to use quite often in problems. Let's try another one here. Here's one that's a little bit more complicated. 12x squared y. And this could have a minus or a plus. This happens to have a minus 20 x squared x cubed y, excuse me. So we kind of go through the problem one step at a time. We look at the 12 and we look at the 20 and we say, is there something common? Well, we can divide both of these by 2, huh? But then we say, well, is there a number that's bigger than 2 that would go into both of those? And we could divide both of these by 4. What about 6? Well, 6 won't go into 20. So it looks like the biggest number we could take out, the biggest common factor, is a 4. So I'm going to factor out a 4. Now we're going to kind of look at those x squares, x cubes. I guess this isn't working. Let's try something else. Here's an x squared, here's an x cubed. What's common to those? Well, x's, they both have x's. But when we're factoring out x's, we take out the smallest exponent between the two of them. So we're going to take out x squared. And finally, we see the last term they both have y's. So we're going to take out that common factor, that common y. I'm going to put a parentheses. So we're dividing 4 into 4 into 12 is 3. But we're subtracting exponents. 2 take away 2 is 0. So that means when we have something to the 0 power, it's equal to 1. So this would be 3 times 1, which is still 3. And here we have a y1, take away a y1, that'd be y0, and again, that's 1. So common factor is 3. 2 take away 2. They kind of cancel each other off. You can kind of think of them as canceling each other. And 4 goes into 12 3 times. Then we're going to do the same thing with the 20. 4 into 20 is 5. 2, 3 take away 2 is 1. X to the 1. We could write the 1, but we usually don't. And then 1 take away 1 is 0. So those kind of cancel each other off. How do I know if I'm correct? Well, I'm going to distribute this. 12 x squared y. 20 x cubed y. So I'm going to multiply this term, first term, times the 3, and then the outside term times the 5x, and double check it. So you always want to double check it just to make sure. Okay. If the problem, sorry, if the problem starts out with a negative, let me get something to drink here real fast. Water here. If the problem starts out with a negative 4x, say minus 24, we want to factor out that negative. So this would be negative 4 times 1x. That give me negative 4x. That would, and negative 4 times a what? Positive 6 would give me a negative 24. So if I factor out a negative 4, these signs are going to change from negative to positive. But we usually like this parentheses thing to be positive. All right. That was example 2. Well, actually 3. All right. Let's try another one. Maybe we have something more complicated. And this is something that a lot of students miss. They miss the fact that you can take out a common factor. Then they try to do more complicated factoring, and it just becomes more difficult for them. So it's a lot easier if you look for this common factor. You should always look for a common factor first. So we're going to take out the negative 2. No x's because this is x squared x, but there is no x at the end, so you can't take on an x. So negative 2 times x squared gives me negative 2x squared. Sign change, negative 2 times minus 3x, negative times negative, positive, and negative 2 times 10, or negative 10 divided by negative 2 is a positive 5. You can think of it either way, like you're dividing these. Or sometimes I think to myself, negative 2 times what gives me negative 10? Negative 2 times 5 gives me negative 10, a positive 5. So you can look at it 2 different ways. Sometimes some people look at it as dividing a negative and a negative is a positive, or some people look at it as negative 2 times what gives me that term. Negative 2 times what? A negative times a negative is a positive, and negative 2 times what? Or negative 2 and a negative 2 is a positive 5. Either way you can think of it. Okay, so you're saying this is pretty easy stuff, but I'm going to show you one that in higher math we come across. Okay, you probably won't get anything this easy, right? I mean, this difficult right now, but you want to realize that sometimes common factoring can get pretty difficult. Here's a problem where it has a negative exponent in it, and we want to factor this out. So obviously we can take out a 2, but what about the powers? Well, we said always take out the smallest power, which is the negative power. You know, on a number line, a negative is smaller than a positive. So you're going to take that out. So what happens here? Do I leave it blank? What do I do? Well, I'm going to put a 1 in there. Negative 2x to the negative 2 times 1 would give me what I had. Plus 2 times 2, of course, is 4. But what about here? What about the power? It's going to be an x term. So you have to think to yourself, this is going to be 2 minus a negative 2, which will be 2 plus 2, which is 4. This is going to be x to the fourth power. Because when you add these, a negative 2 plus 4 gives me a positive 2. So sometimes they, even though, it seems pretty simple that you're just going to subtract the powers, you might think that this is 0. You're looking at 2 minus 2, but it's really 2 minus a negative 2. So sometimes in higher math, we encounter this quite often. And you'll be dealing with these negative exponents. A negative exponent, we can change it to a positive exponent by just bringing it down to the denominator. So I can bring this down and write it as x to the positive 2. It doesn't make the problem negative. It changes the exponent from negative to positive. So the final answer for this problem would be 2 over x squared times 1 plus 2x to the fourth. See? So I just wanted to show you that where, sometimes people say, oh, this is really simple. Well, it is sort of simple until you encounter these with negative exponents or fractional exponents, or, you can run into all kinds, because in higher math, we run into a lot of fractional exponents too, where we're getting something like that. So, that's why it's good to know, understand how to factor. All right, let's see what else can we do. Any others? I'm going to pick some off the assignment. Here's one, negative 3y squared plus 24y. So first of all, I want to factor out a negative number, and I see 3 can divide into 24, so I'm going to factor out the negative 3. Put a parentheses here. I also see that there's a y squared and a y. The y doesn't always have to be in the first term. We want to take out the smallest y, which is y to the power of 1. So this would be y to the power of 1. You can either divide, or you can say negative 3y times what gives me negative 3y squared. That's how I usually do it. I just kind of think, okay, but I can also factor it out. I can divide. And sometimes in higher math, we end up dividing. Okay, here I have a sign change. This is going to be a minus. This is going to be 8. Give me a 24, and y to the 1 times just the 8, huh? No y here. We usually don't write y to the 0. So this would be negative 8. Double check it by distributing, and you're okay. Negative times negative, positive. All right, any others? Let's try this one. (15x cubed y squared). Problems like this come up quite often. Going to take out a 5, common to both terms. You can see smallest x, x squared. Smallest power of y, y squared. So that's my common factor. 5 and the 5 goes one time. You can write it down if you want, or not write it down. 2 from 2 is 0. 2 from 3 is 1. Sometimes it's good to subtract those exponents. Makes it easier. Plus, divide the coefficients, but subtract the powers. 2 from 2, 2 from 3 is 1. 2 from 2 is 0. Double check it. 5 x squared y cubed. 15 x cubed y squared. All right, the other type of factoring is what we call grouping. Instead of just taking out a single variable like a y or an x, we take out a parentheses. So let me put one that's already in the right form. This is example 8 in your book. When we do grouping, what we try to do is we take out a parentheses that's common to both terms. This is all considered one term, and this is one term. They're separated by addition signs. And when I noticed that on this particular term, this is this a minus b is common to both terms. So I'm going to factor that out. I'm going to take out that whole thing, which means it's basically gone. Then I'm going to write down what's left. X plus 5, maybe put a bracket around this, plus x minus 3, y cubed. Huh? So it's a minus b times this whole thing. Well, since this doesn't have any powers on the outside, which you have to contend with first, we can just combine these like terms. So this would be a minus b, x plus 5 plus x minus y cubed. And then you could put the x's together. So it'd be a minus b times 2x plus 5 minus y cubed. And these could be in any order. So this would be our answer to that problem. So first we take out a common factor, but the common factor this time is in a parentheses. So what we're trying to do is write down everything that's left. Kind of weird, huh? All right, let's try something else here. A lot of times these problems are not factored out. So let me show you this one. And the directions would be factor. Simple. But you can see if I try to take a y out, which looks like it's common, it's only common to a couple of the terms, 3 of the terms, but not to all 4. It has to be a term that's common to all the terms. And here we can divide 12, we could divide it by 3 or maybe by 4, but it's not common to all the terms, so we're kind of stuck. So what we do in that is we pair these off. Usually, there's other ways we do it sometimes. The most common way is to pair them like that. Put them into pairs. Then we can factor out this pair. It's common. We see they both have y's, so we're going to take out, and the smallest y is y squared. So we're going to factor that out. 2 from 3 is 1, plus 3. 2 from 2 is 0. Then we look at the next parentheses. Here we have a 4 and a 12, so we're going to take out the 4, common to both terms, and this gives me y plus 3. So if you've done this correctly, they should have a common parentheses. If they don't, then this method doesn't work, but they should come up. So what I usually do is I take out that common parentheses, y plus 3, and I'm going to cancel it off. And then I'm going to see what I multiplied it by. Y plus 3 times y squared gave me that first group right here. And then y plus 3 times 4 gave me the second group. See? So I can take out a common parentheses. Y plus 3 times y squared, y plus 3 times 4. So I kind of just look what's left, y squared plus 4. If I take it out, it's gone. And what's left is the y squared, the plus, and the 4. So this is what we call grouping. All right. Let's try another one here. Sometimes they get a little complicated when they have a minus sign. And then I'm going to give you a hard one. It's not in the book. Okay, when this happens, what we want to do is kind of do a chick on it. It's probably the easiest way to do it. Because we're going to separate by the middle term, let's change this to addition right here, right in the middle. Let's put a 1 there plus a -1. And then we'll group them like this. Because with minus signs, it's always a little bit more difficult. So you want the term that's right in the middle to be a plus sign between these two terms. Okay, so here I can see I can take out a 3x squared, and I get 3x squared times x minus 3x squared times what, 2? Double check it by multiplying it. Yes, distributing it. But here I want to take out the -1. And this would give me a x, and a negative times a negative is a positive 2. That's why I wanted to change this. I'm going to take out this -1. Negative times x, negative times 2. So they're always a little tricky. And then I can take out my common factor. I'm going to cross it off. X minus 2. And what's left? I got 3x squared. And instead of writing plus a negative, I'm just going to hit -1. See? Okay, I'm going to show you a little trick on this problem also. It's called the cheater's way of doing it. Let's say you factored this out in a hurry and you took out your 3x squared, you got your x minus 6. Then you came to this term. Okay, and so you put a minus here, and you got an x plus 2. This should have been x minus 2. When that happens, there's a good chance you made a mistake in here. And what you want to do is just kind of change it to a -2. Because a negative times a negative is a positive if you distribute this minus sign. When you write these down, you need something here. You can't just have a minus and nothing there, so you have to put in the 1. But you can double check. A negative times a positive is a negative times a negative is a positive. So you can do it without being quite as formal. You just have to be careful. I'm going to show you another interesting one right here. Let's see if I can write this correctly. This is similar to the one we just did. Whoops here. Let me try it again. I'm trying to make up this problem as I'm kind of writing it down. There we go. Let's try this one. Okay, so what am I going to do on this one? I'm going to take out parentheses right here. Maybe change it to addition, chick, just to be safe side. And I'm going to take out a 3y squared like I did before. This won't work. Oh, not a 3y squared, just a y squared. And here I'm going to take out a what? A -4. And that'll give me y plus 3. There we go. Now I'm going to put these together. Here's my y plus 3. You want to watch this one carefully. And then I've got y squared plus a -4, so I write that as -4. And most students think I'm done, but you're not. What about this one? You see, this is a pattern that later on can be factored down. So we can factor this a little bit more, and we're going to get into that a little bit later. So this particular problem could be actually factored into y plus 3, y minus 2, y plus 2, and you get pretty good at this later on. So this could be factored even more. And that's what we always try to do. But for the time being, you won't run into that, I don't think. I'm going to try one more of these. Let's see. This is a pretty horrible problem. If we can do this one, we could probably do any of them. Well, at first it looked like I could take a -4 out of everything, and I can't because of the 3. And we see they have M, so I guess I will have to pair this. Pair it up. Okay, so about the only thing I can take out of here is an M cubed, right? But I might also take out the -1 M cubed and make this positive in here. Let's see, that would be a positive 4M plus 1, 3. What am I saying? Okay, negative times positive is negative. 3 plus 1 is 4. Negative times 3 is -3. And the 3 comes up. Plus, what about this one? What's common to both of those terms? Probably a 4, huh? Was this a 64? Let me double check it. Yeah, it was. This was a 32, though. I wrote it wrong. So that was a 32. Let me write this again. Oh, that's where I made my mistake. And sometimes copying these. You could usually tell because the 2 parentheses were not going to be the same. Okay, let's try it again. Now I could take out a -4 on every one of those terms, huh? I could take out a -4 on this term. So let's take that out first. M4 plus 8M cubed minus, see all these signs are changing, 16 times 4, let's see, that's 64. M plus 3. See. Now, what I might think about is next, I took out the common -4. Could I do this by grouping? I don't think grouping is going to help me because you could try it. I'll just go ahead and show you. But all we could take out of this one would be an M3. That would give me M plus 8. And on this one, I could take out nothing, a 1. And I get 16M plus 3. So grouping doesn't help you unless both parentheses are the same. So this would be a problem where you don't want to really do grouping. You just want to do your regular parentheses like you had. Take it out a -4. So I'll let you mess around with these a little bit, see what you can do. Try problems 1 to 31 and 37 to 54, maybe the odds. See what you can do with them. Any questions? Anybody have any questions?
I don't have any questions.
I'm good, thank you.
Okay, well, give it a try and see what you can do on these.